switch was closed, it went here, right? And then the negative on the side of the same battery charged up the negative rail when this switch was closed. Now they're both open and they're flying back. This negative now becomes a positive. This positive here becomes a negative. This negative flows down here through this high voltage diode into the negative rail of the other battery. Right here. These high voltage caps system, including the Bedini system. Okay, so the mouse is visible. I'm going to zoom in here. So this is basically based off the Bedini SG system. And I want to focus on these two inductors here. And the high voltage flyback diode right here on the bottom inductor and over here on the top inductor. So both of those flyback diodes are a key part to this whole system, including the Bedini system. Without them, you wouldn't be able to capture the flyback into a battery or rectify the flyback for that matter. But that's how the Bedini circuit works, basically just like this. So if you see on the left side here, you got source power at 12 volts. Let's suppose this is the drive battery. So the left side here is your positive, and 12 volts will exit out here with the Zener diode, 12 volt Zener. It'll go up the rail, and when this switch closes, it will feed positive to this side of the inductor here. And the positive from your battery will pretty much end there, because if you look here, when the positive from the source goes through the closed switch here to feed this inductor, it will close when this switch closes. These two switches will close at the same time, and basically they're switching the positive and the negative of each inductor, of each drive coil. So here's the negative side of the drive coil, and here's the positive, and when this switch closes, connects to the negative here of your battery.
Hey Mike, how's it going?
So these diodes here, they prevent the negative from going that way. These two diodes, the negative will not go that way. Negative will only go this way. And I'll talk about that when this inductor flies back negative here, it goes that way. So we're going to charge up the bottom coil with forward power from the battery, forward voltage. Plus here, negative here. And then, Mike,
Hey, yeah, I can hear you fine.
Yeah, it's a playback. I'm just playing back another video I did.
Oh.
Just explaining the two switches there.
Yeah, kind of a review for everybody.
Yeah. Can you hear the music with it?
Very faintly.
Let me see. What is going through? Is it louder now?
Yeah, now I can hear it, yeah. Yeah, I can hear it now.
And how about now?
Yeah, it's definitely louder than before. Before you had
it's coming through my mic. Okay, I see. It doesn't go through this. It doesn't go through the. Yeah, I was going over this circuit here. Well, when that happened.
Main thing I would say to everybody who's working on this stuff, experiment with different diodes. I've even had some interesting experience, but the diode in backwards, like a Schottky diode. If you put it in backwards, you get a pretty weird effect with it. And sometimes it actually helps.
You mean like not putting it facing the what's the line? The line is the anode, right?
Right. So like the line is the direction that it's going in. So if it tries to go against that line, it will go back. But with
direction of the positive, that's the direction of the forward voltage.
Right, forward voltage, correct. Now with Schottky diode, it'll let some of that power trail backwards. But I've heard of some guys, actually, a friend of mine, apparently his friend's a NASA engineer, and he was doing some back EMF tests, and he found some interesting effects with a Schottky diode, and he put it in backwards. And I tried it, and yeah, there is an interesting effect there with back EMF. So it allowed you to go back, charge it back. Yeah.
So he pointed the anode at the negative.
Right.
Oh,
he reversed it. Yeah, he reversed it right next to the inductor, whatever coil you're using, he would reverse it. So the back EMF would actually go hit the battery or the source, right? And then it would ricochet back into the coil again and create a reactance scenario in the coil.
That's strange because the back EMF will go through the diode the obvious way as well.
That's right, it will, depending on what the leakage value is on that diode. So if you choose a Schottky diode, they're usually quite a bit higher of a leakage. You can actually check a chart.
And low frequency or high frequency?
It would be a high frequency.
Low frequency, probably no leakage. Right?
Yeah, the lower frequency, the less leakage. Higher frequency, you get more leakage. That's what I understand, anyways. But yeah, you have to experiment with many different types of diodes, especially right next to the coil that you're using to generate the back EMF spike. Now, that's part of the reason why I've always used a disruptive discharge switch with it.
Yeah, you're talking about a spark gap when you say disruptive discharge.
Right. So what I do is, like, you could go to your local UAP or Automart or whatever and pick up a 12-volt automotive relay switch. It's a single throw switch. That's what I use in all my pulse motors, and I would get the best reactive energy flyback into the coil. It's reactive.
You control your frequency with that. You have to use the pulse width.
Well, it has to do with the speed of the motor, right? So the slower the motor goes, your pulse width or your duty cycle is larger. The faster the motor goes, your duty cycle now decreases. Right?
Well, what do you use to trigger your spark gap?
I use, to trigger the spark gap. Now, this relay switch is an isolated switch. So the actual trigger is isolated from the actual line. Okay, that on and off.
So you're like disconnecting source from your spark gap.
Right. So what I use is a 3D printed proximity sensor.
I never thought of doing it that way.
Right. So I tried it out and it worked fantastic. So I have a separate power source that runs the relay switch as well as
What kind of switch was that again?
It's a 3D printer proximity sensor. Right?
That sounds like a switch that can handle that.
And well, the funny part is, it's the only electronic.
You're still gonna get an arc in that switch too.
Sorry,
you're still gonna get an arc in that switch that you use to control the spark gap as well.
Oh yeah. Oh yes, you do. Yeah, you definitely get a spark, and you get that bluish green spark that Bendini talks about. Okay, that's the radiant energy spike. So when I start doing the experiments initially with the spark gap switch and using that proximity sensor as the trigger, I start to see that bluish green spark show up, and I'm like, aha, this is the radiant.
Where in the spark gap of the car?
Right, in the automotive relay switch. If you take the box off it, you can see the little contact open and close. So I did notice from a stock one that you just buy right from the store that it would trigger, but it wouldn't trigger that fast. So all I did was I took needle nose pliers and bent the armature closer. So instead of having, say, a 2 millimeter gap, now I got a 1 millimeter gap, and the thing triggers twice as fast. And
but it triggers for your printer relays.
Okay, so yeah, I'm glad you asked that. The closer
for your relay of the printer relays.
Right. So the closer you put that proximity sensor to the rotating magnets, the duty cycle increases. When you take the proximity sensor and you pull it away from the magnets, the duty cycle decreases. All right. So the trigger actually gets faster as you pull the proximity sensor away.
Yeah, because you got less grab on the magnetic field.
Exactly. And I start to notice this bluish green radiant spike coming off that switch. Now, in most electrical circuits, most guys would say, oh, that switch is going to burn out. Well, guess what? Mine never has. And I've run it for hours and hours and months and years on end.
What voltage?
Well, at that time, at that time I was running 12 volts. But now my newest motor, I'm taking more of the Newman approach to my circuit, and I got 100 volts DC going through that switch, and it's only made for 12.
Same switch.
Right? Same switch, and it doesn't burn it out.
It's only made for 12 volts.
That's right. Now try to explain that one.
well, you're not supplying current to this.
Yeah, because the current's generated in the coil.
On the reverse flyback section, not your section. The forward section is your power, through the switch.
That's right.
And
The real,
you're not allowing the reverse flyback to go back through your spark gap because it can't, for one.
that's
Instead,
right.
it's going through the diode.
Exactly.
You're giving it a load.
That's right.
Yeah, that makes
So,
perfect sense.
and because you're giving it a load, now what happens is that collapsing field in the coil, depending on the size of your coil, like most of my coils are at least 1 pound. The one I have in my Renegade is 2.2 pounds of 24 gauge wire around iron rod, the iron rods you use for welding. I use those
Mhm.
rods and I isolate those, each and every rod. I isolate them with electrical tape and I put them in one by one.
Is that
So
your core material?
yeah, exactly. So because of that, the flyback is enormous, and also the amount of current is huge. So I put in, say, I think it's 40 milliamps, and after I do the flyback, I'm getting over 1.1 amps coming out of the coil. So I'm getting, number one, a huge voltage gain. Number two, I'm getting a massive current influx. It's just
Yeah, that's from that's coming from the flyback.
That's right.
Flyback.
Right, because voltage creates current. Okay, if you go back to what I have an interview with Eric Dollard, and he's talking about this, and he says a lot of people just don't get it. He says if you got voltage, you got current. Okay, if you
Of
have
course,
current,
even if you don't supply the current, you still got current from somewhere because you're creating the potential.
that's right. So just listen to how he words it. He goes, if you got voltage, you got current. Now, if you got current and you put it through an inductor, well, now you have magnetism. Well, if you have magnetism, now you have electromotive force. And if you have no voltage, you can't create electromotive force. You need the voltage in order to create the electromotive force through magnetism. So it all starts with voltage, your potential input. If that makes
you
sense.
could have low voltage, 2 volts or something.
Yeah, you'll get a gain, but he says if you want to get a real rocket system going.
No, what I'm saying is you could have 2 volts pushing 1,000 amps, but it's not going to go very far.
That's right. That's right.
It's,
You'll have a giant punch, but you won't bounce back very far. There's not enough electromotive force. You have to have that voltage potential. That voltage potential drives the EMF.
You can limit your current, raise your volts.
That's right. And that's how the Newman motor works. He uses a very large inductor. He knows if he puts in, well, his motor, he put 460 volts DC at 50 milliamps.
So what you're getting at here is this whole thing about switching, high-speed switching an inductor on and off, just fast enough to not keep a load on the inductor too long, so
right.
You don't waste
that's
energy.
Right. And that's why Newman was able to use dead 9-volt batteries to run a 4,000-pound motor. It's because
what did he do with the flyback?
The flyback, he dumped it into capacitors, and he was.
He never showed that. I never seen that.
Yeah, he never showed that, but he used to dump it into capacitors. But his over unity gain, and a lot of people don't understand where his over unity gain came from the electromotive force, the actual amount of horsepower.
What did he do with the buildup in the capacitors? What was he using that for?
Nobody knows. He never showed that, and I would be very interested to see what he was. I knew he was taking some of that flyback and recharging the batteries as he was going, but right. And what he was doing, his over unity was the back EMF electromotive force to use to push that 4,000-pound motor. That's where the over unity is, not from the flyback. It's from the electromotive force he was creating. That's why.
Read what Jean-Jacques said here. This makes more sense here. See, you need electromagnetism, right, to tap into the gravitic magnetic field, and that's what the flyback's doing.
Right, and that flyback is bouncing off the ether. All right, when you get a high voltage, high potential, and even if you were to add like what I'm doing with a spark gap switch, and to boot on top of that, I put in parallel a transducer. I just had confirmation from a professor just recently saying that I'm actually bouncing my potential off the Planck, which is the lowest denomination of matter, is through piezoelectric. And now I've kind of confirmed that by somebody who's actually a physicist that actually says you can bounce electrical potential off the ether or the Planck scale by the use of piezo transducers. And that's what I'm using in my Renegade. That's why I'm getting the massive gains in power of over unity. That's why I'm running the motor at 60 volts and it's only drawing 10 milliamps. Actually, my meter half the time won't even register the current draw off the battery.
Like that's high enough frequency.
I'm in the microwatts. I'm down in the microwatts of drain off the battery. So when you got 60 volts of batteries at 12.6 volt batteries, 60 volts or 50 volts, it doesn't feel anything when you start drawing power off it because it's not running off currents, just using the potential to start a reaction in the coil. That's what it's all about.
So let me tell you what I know about this reactive force here. okay, with AC.
Tesla talks about it too.
So when you throw this AC into an inductor, initially the back EMF in the inductor, I'm sorry, in the core, sorry, is going to push backwards.
It'll go in both directions.
Well, no, wait. At first, right, you're right, but at first it pushes backwards. And as you keep your AC going on and off, on and off, up and down, you keep your AC going. Your AC don't give up, but
That's
initially
right.
when you turn the switch on the AC on this inductor with a core, the back EMF in the core pushes back on it initially, and,
Right.
and after a few seconds or so, it goes with your forward voltage.
Right. There's a collision
then-
that takes place.
So in that way, you're not taking advantage of any of the back EMF. You're not creating an on cycle. You're not creating an off cycle with AC. AC is there's no off cycle. That's negative,
right.
but it's not
It's a
off.
wave. It's in a waveform. That's why. So that's why a DC pulse will always work better than an AC, because an AC is a continuous wave. Where
Oh no, I would say that you can combine DC pulses with AC and their peaks and get some crazy results. You know.
I'm sure you could with a lot of experimentation, and that's what I tell everybody. You have to experiment with this stuff. I didn't come up with the Piezos just overnight. I was experimenting, and I had these little transducers, the ones you have in like your singing letter cards, So I grabbed one out, and I saw some guys working online with transducers making sound and stuff. I said, okay, I'm gonna throw this on my pulse motor, and then my gain went up 30%. I'm like, okay, what just happened here? And lo and behold, I didn't realize what I just did. And I knew it was special because the gain I was getting was like really obvious on the meter.
So I was looking into the VTA, the Floyd Sweet vacuum triode amplifier.
I made that, yeah.
So that's a very simple concept what he's doing there. He's just wrapping 3 coils around one
Yep.
magnet, right?
Well, I've spoken with Norman Wutan personally. I actually
Name rings a bell. I'm not sure who he is though.
well, he's one of the guys who created the VTA.
Okay.
Or sorry, the MRI device. Sorry, the MRI device.
Oh, the MRI.
Yeah.
Okay.
It's the magnetic resonant amplifier, MRA device. Sorry.
Yeah.
So I spoke with him.
MRI is right. Yeah, magnetic resonance.
Sorry, VTA is. You're talking about Floyd Sweet's device, right?
Yeah, the vacuum triode amplifier.
Oh, okay. Sorry, my bad.
Yeah, he's doing the 3 coils around one barium ferrite magnet. So, interesting though that whole concept. It's just one way of looking at things. With
Tom Bearden was talking to him on the phone one night. He was doing an experiment. I don't know if everybody knows this story, but he told him to short out the coil while he had it running. And when he did that, his device lost 90% of its mass. It started hovering on the table.
All right, getting back to that whole thing, right? The gravomagnetic is what I was trying to go out here.
Yeah.
That's the whole thing with these off cycles. When you allow an off cycle to happen,
yeah.
You see, your forward voltage is not going to be part of the gravomagnetic. That's part of the electromagnetic.
Right.
Now, the reverse flyback is not your forward power. It's just the opposite equal reaction.
That's right.
We were talking about.
That's right.
I don't believe it's coming from your source, though. It's just you just stimulated it through your activity. It's a scientific thing.
Yeah, I think
it's a thing of physics. There's the opposite equal reaction. You stomp your foot on the ground. Yeah, sure, the ground's going to vibrate, but so is your leg.
That's right. So basically, what I found out with the transducer on my inductor, it would put my coil into harmonic resonance like instantaneously. So it didn't matter what size of coil I had. That transducer was that little chime that you're able to ring the bell. It had the right frequency to ring the bell.
Well, the transducer is just 2 plates really close together, but not touching.
Yeah. Well, what it is, I'm using a barium titanate now, a barium titanate transducer, and it's incredible the results I'm getting off it. It's just truly amazing.
That's taking advantage of the Casimir effect.
Yes, and the Casimir effect is the only force that I know of that can rebound off the Planck, which is the smallest denomination of matter or energy, that wave. And now I got confirmation from another doctor that did similar experiments, and he talks extensively about the transducer piezoelectrics, the Casimir. So it's kind of funny.
Is that a biophoton that's measured in attoseconds, or like at least 25 attosecond wave?
It's we hear you. I know, Bill. I don't know how to answer that one. That's a scientific one. Biophoton.
Photon.
Okay, so yesterday or the day before yesterday, I was listening to a Nobel Prize winner measuring the attosecond. But how she measured the attosecond? She created an infrared. She beamed an infrared light at the atom to knock off the electron, and then reversed the infrared light, so it pulled it back again. So it created this like a magnetic like a repulsion and and then absorption, repulsion. So it made like a yo-yo effect, which created like static energy. So when the static energy, like when electron hit the atom, it released a biophoton. That wave was the smallest unit of light or energy produced by, and it's like the time length of it is called an attosecond.
It sounds like infrared or something.
Well,
No,
Heat signature.
it's a lady. She's the one. It's a lady. I think she's
They were-
a physicist.
yeah, they were doing some experiments in Germany where they were actually using a
I think when they took a
photon.
picture of a hand with missing fingers and they can still see the image. Maybe that's what she's referring to. What's that called again?
I took snap images of like how they explained it, but I don't know how I tried posting them right now in the chat, but it didn't. It doesn't accept like images. Only typing.
Well, they're actually starting to prove now that photon can actually create matter. They've been doing some experiments in Germany. I forget the name of the laboratory, but they were successful on bombarding photons together and creating a matter particle. So there could be some correlation to what you're talking about and the photon, what it's actually doing.
Thank you.
There's so much going on in physics right now. It's pretty crazy.
Is that anything to do with that thing where missing limbs are still showing images of their? What do you call that thing? That photography again?
With the stop motion, or
No, there's these people taking pictures. There's special cameras to show where people have lost fingers, but they still show an image of a finger.
oh, almost kind of like the ghost effect. After you lose a limb, you still feel like you got the limb.
No, but they actually got pictures that show the rest of the limb, even though it's not there.
Wow, that's crazy.
Are
I
you
can't remember the
talking
type of photography.
about photo filters or like things like that?
Well, don't forget, don't forget your body is energy, right? So irregardless of the physical matter not being there, there's still, I would say, a chance that the physical presence of the energy that came from that matter could still be there. If that makes any sense.
Okay, so my dad is an orthopedic, and so he dealt a lot with having to amputate people's, things, accidents, or diabetes caused. He said that the nerves never forget the part that got removed. So he said something like a phantom effect.
There you go, phantom. There, the phantom.
Yeah, like the nerves never forget, even if that part was removed, that something needs to be there. And so like a lot. I think this was like maybe 10 years ago. I heard him talking to somebody about this. Like the body will always think that the nerves will think that there's something there, although it's not. So I don't know if that helps out. But, yeah. And I think the prosthetics that they actually use to for people that lost any limbs, the nerves are the ones that dictate like the motion for the fingers or feet or on that, because nerves, again, they don't forget. They don't. Yeah. So it's just pulses from the nerves where they were supposed to go, and that's what the prosthetic senses, the sensors inside of it, and for movement. I don't know if that makes sense.
Yeah, no, totally. I got an image. Look at that image. Look at that link right there. Hold on, I'll bring it up. They got pictures of this already. Where is it? There you go. What is that?
I don't know what happened. I think he got knocked out. Maybe.
Everybody hear me all right?
I think Mike somehow got maybe knocked off of the stream.
Oh, he got knocked off his own stream.
Huh?
He got knocked off his own stream.
Oh, there you go.
Okay, back, Mike.
Yeah, you hear me?
Do you
Yeah, blind
smoke?
here. You said
You smoke? I'm patenting an idea for smokers because I smoke, and I'm working actually on this today. Let me show you what I was working on. You see this little pocket? You can put the lighter in it. I was actually today talking to lawyers to see if I can get like a patent utility for the idea, or call like Marlboro, or to add this little addition to it. Isn't that cool? Like you'll never lose your lighter ever in your life.
Oh yeah. Actually, you know what? I have seen that before. A long time ago, I had a cigarette pack. It was made out of vinyl, I believe, and it had like a little thing on the side of it you could put your lighter in. But it was too
They
bulky.
don't have it. I looked. They don't have it. There's nothing. I looked up and down for this idea. It doesn't exist. It doesn't exist. I'm telling you, it doesn't exist. I'm like trying to, like today, like my whole day I'm working with like different attorneys to see if I can get something called a utility patent on this idea. It's cool.
Yeah.
Like it's like they
Well, they could do a patent
you know,
search. Right?
what's the difference that like the coffee cup sleeve, the one to protect your hands from heat. Well, it's kind of the same idea.
Yeah. Well, do a patent search on it, and they can tell you for sure if it's been done or not, right?
Mike, what are you showing us? X-ray of a hand missing something?
That's the phantom type of images they're getting from biophotons or whatever.
Are they reconstructing like the existence of like?
Well, you see the middle finger or whatever. It's the bone is not there, but neither is that skin. But I don't know.
Light force energy.
Wow.
Light force energy is still there. The matter, even though even though that the matter is
I
not
don't know.
there
Can you see the
anymore,
mouse
the energy's
pointer?
there.
Mouse pointer up there. Right where the top of the bone there is where the finger's been cut. And then there's that top ridge like you see on the other fingers. And then there's this phantom of image of looks like it's trying to regrow. The finger. So they got more images of this. I've seen this over the years. So.
I don't know. Like we have to know more context of the because they could use stem cells to regenerate missing cells.
Right.
So if they're like infusing the area with a lot of stem cells, it could have the potential to mimic the cell structure that it's being put on and grow a bone or grow.
Well, your liver in your body actually grows back. A friend of our family, she got really sick, and they had to remove half her liver, and within about a year, her liver grew back. So
yeah, the liver's the only organ in the body that can fully grow back.
Yeah,
it's incredible.
Yeah,
the kidneys grow back. So,
they're starting to realize that too. The kidneys, they thought they couldn't grow back.
No, I know that for sure because my ex-husband had kidney cancer, and then they did a partial nephrectomy on him. But like when doing the scan, that was like a couple years ago. Well, the kidney looks whole again.
Yeah. So if they can pinpoint the gene that's responsible for that, you can grow back your limb just like a frog would, or certain amphibians can grow their limbs back, right?
Well, that's the thing. It appears anything can. Proper nutrition, I guess.
What do you think? It's like photons aligning themselves in that energy field to, create that hologram of the missing bone?
Light force energy. It's your light force energy. It's still emanating energy from your body as if the limb was still present. See, I've developed a meditational skill where I can basically shut off pain in my body just by going into a meditation state. I pretty well perfected it. Now, Tesla was doing some work on healing pain. He developed a vacuum tube plasma, and if you rub that plasma tube over your body part, it would alleviate pain. Now, John Hutchison, who I've known for years, has one of the original Tesla machines. It still works. Now, the FDA had that machine removed from the market around 1939 because they started dipping into their money for pharmaceuticals.
That was after World War I, but before World War II. Okay.
Yeah, similar. Yeah. So yeah, John, actually, I've seen the video where he shows that device. It's pretty amazing.
Oh, I saw it. I was on the APEC conference when he was a guest, and he did a lot of things, live on this the APEC conference, live stream. Yeah, I met Hutchison and his wife. Like, my gosh, these people are, out of this world. Really out of this world. Like, just, and they use like antennas, communication.
A party animal might be an understatement.
Create an energy field where they pretty much can disappear. Nobody knows where they're really located. They can keep on proxying their location. From one place, the signal keeps on jumping. But it's amazing, and they do that with things that they planted close to these, little gadgets. Those little gadgets take their energy from the main wireless antenna. These guys, I'm telling you, if ingenious is ingenious, that's the definition of ingenious.
I vaguely remember him talking about something about that. I used to follow him 10 years ago when he was making more videos. Before I even knew how to use YouTube.
Bad sciences.
He quantumly locked, entangled a state, but he sent a girl to Egypt, to the pyramids. But somehow he entangled the frequency to bypass all of the frequencies that are registered, what we use for telecommunication. And he created one that he can communicate with this assistant through that entanglement state, and bypassing everything that we know of how to transmit a signal. He flipped a bit, if it was a positive for him, definitely it's going to be negative for her. So they created a language just so, you know, to see how far that transmission can go. And he did it somewhere in the United States, and she was in Egypt in the pyramids. There's a video about that if you want to watch it. But yeah, I mean, it's just like, you know, these people, if we want to say aliens exist in human form, he's one of them. I'm 100% sure.
Yeah, I can't argue with that one.
Who's to say we're not all aliens?
Yeah, that's a whole different topic.
Yeah. No, I'm going to be quiet. I'm going to put myself on mute and close my screen. I want you guys to continue what you guys were talking about. You know, right?
About the flyback.
Yeah.
See, that's the whole thing. The flyback is not forward voltage. It's not positive voltage.
No, it's the impulse.
It's not your energy coming from the battery. That can be proven in the head. You don't even need to do it on paper.
Yeah.
You know, because it's not happening when the switch is on. It's just not happening when the switch is closed.
Yeah. So the power obviously has to be somewhere. So
exactly. You're opening up the circuit. There's nowhere for your energy to flow anymore. Yet
right.
something's flowing.
Right. And where is it coming from? Direction. Right. And it's coming from counter space.
And I still believe that word opposite is a dead giveaway to Tesla creating that phrase.
Yeah.
He might have even, the original word might have even been reverse, not or polarity, not opposite. You're
well,
muted.
You know.
Oh, there I hear you guys.
Am I muted?
You were for
Oh, okay.
You're good now.
Yeah, like Tesla was into, you know, basically ether, you know, the concept of ether and the dielectric field. The dielectric field is probably where this excess of power is coming from. There's no other place where, well, you know,
I mean, the dielectric must be this Kashmir effect of signals just bouncing between two things.
That's right.
Because there's no connection here. There's other.
That's right. Like, even Bendini had an explanation. He says, okay, if I put 12 volts into this coil and I let the back EMF happen, he says, at sea level, I should only get, by regular physics, I should only get 12 volts back. But he says, if I increase the potential or I increase the elevation of the inductor, say like go up on a very large mountain, he says now your back EMF spike is now going to increase exponentially. It's actually proven. So elevation has an actual effect on back EMF coil or flyback. So he lived near, he was in Idaho at the time, and he was going through, I believe, Salt Lake City in the mountain area. And he did these experiments. He found his inductors putting out more power at a higher elevation. So obviously, the power has to be coming from the atmosphere, or dielectric, or ether, whatever you call it. So there is, I think, a correlation to that. You know, what we're talking. So I'm probably going to do some experiments on that myself to kind of prove it for myself that elevation can actually improve the back EMF spike, which I think it would. So I'll have to do that. I have mounted, I live right at the base of the Niagara Escarpment, Ontario, Canada. So I'm not too far from the falls. So I'm right at the base of the north end of the Niagara Escarpment. I can actually see the escarpment from the house. So that is, I believe, 250 meters. Yeah, probably more, probably closer to 500 meters high. So that should show me some kind of result.
Is it the temperature? Is it the temperature that when you go higher in elevation it changes?
No, it's the static potential of the atmosphere.
Okay.
So for every meter, you're supposed to increase voltage by 120 volts per meter. So if I go up that high, I should be getting back EMF getting 500 to 600 volts. So
with just the same setup, nothing changed, and you're not adding anything, just the same
that's
thing.
right.
Wow.
That's right. Yeah.
Wow. Okay, so people that live on higher, you know, platforms.
I got one of these. They're super bright. It's the Tesla's first bulb fluorescent. This is Tesla's idea for a fluorescent bulb, and I have one.
Yeah. And it was a different kind of light too.
They're right, ring.
Full spectrum. Not like the fluorescent tubes that we have today. They flicker at a very high rate. Apparently, it's not very good for our brain function.
Well, I got one. It works beautifully. I've never seen such a perfectly bright. If you need a lot of light to work on a lab, that's the light. And you don't get annoyed by those traditional fluorescents that easily go
more
bad.
Like a full spectrum, like a full spectrum type lighting.
It's got a little bit of yellow to it, tiny bit.
Now, have you ever tried putting it beside a plant to see if it'll help grow?
Yes. You can imagine. What?
Does it?
Oh yeah,
have a
no,
chart?
they did great in vegetation. Not so
Oh,
much
yeah.
in the other cycle, but
Yeah, so I figured, yeah.
oh yeah, I used it. You use it for both vegetation and fruiting. You just keep it.
Yeah.
You just add more yellow, red.
That's what you need for grow light.
But
Yeah,
I bought it for having a bright, really bright one light that was really bright and small and compact. And I wasn't even looking for the Tesla volt. I was just looking
Right.
for that.
How many? Do you know how many watts it actually pulls?
I think it's like 100. Oh, I'm sorry. It's like just under 80 watts, but it just shines like a 200 watt or 300 watt.
Yeah.
It shines really nice, and it works really easy on a potentiometer.
I got actually I got some surplus stuff. I got a spark gap, vacuum tube spark gap from a radar system from circa
How do
1945.
I?
Actually, I could show you.
How do I allow you to share screens though?
Hold that up.
StreamYard.
I'll actually show you.
Oh wait.
Surplus. It's a spark gap from 1945, the original package.
Magneticus. You know, I had a dream once. I was in the hull of a ship, dropping log-sized, perfectly smoothed out cylinders of wood into a hole in the ship that was the same width as the wood cylinders. And I think the cylinders were rolling down, creating some kind of static energy.
Okay, here's the box.
Wait, hold on. There you go.
Look at the date.
What is this again?
It's a vacuum tube spark gap from 1945. It was part of electronics for a radar system.
That's nothing like a guitar amplifier or tube, is it?
Nope. A little different. I'll show it to you in a second. So the issue date, acceptance date, 3rd of March, 1945. Right, I'll show you this spark gap. So I got a whole whack of these through a friend of mine that sourced it from an old guy who lives in Southern California. There was an army surplus and they were basically shutting down. The guy said, okay, whatever you want, you got 48 hours to take what you want. So here's the spark gap.
That's nice. That is a spark gap. It's like
Nifty
two
little
spark gaps.
Nifty little machine. And the amazing part is that here.
It's like more than one spark gap in there.
Five.
Yeah, it's double. It's a dual spark gap.
Two grounds,
One side,
one
Positive.
or the other way around if you want.
Now I have pictures on my YouTube channel of this in action, and I'm able to make it all white inside this. Using a Don Smith type setup, I was able to make all white inside this too.
Like
So
five.
pretty
What's the name of that video?
plasma ball. It's in my YouTube channel. It's in actually it's in my community section. You scroll down, you might be able to find it here. I got pictures of it showing it. But yeah, pretty unique. I got a couple of these spark gaps. This one's the smaller one. I got another one that's like 3 times the size, but from an earlier date. But yeah, I got a whole whack of them.
Well, what was the name of the video again?
It's not a video. It's in the community section where I do posts. I'll have pictures of it there. If you scroll down, you'll eventually hit it. I got some nice pictures of the actual plasma inside the tube.
The top one in the community here is Stirling engine.
Yeah.
Is it down further?
Yeah, way down.
Scroll down.
Let me just share the screen. Bear with me on the YouTube stream. You should be able to see where I'm at here, right? You going down?
You still there?
Yep.
Oh. So you're on the community tab, now scroll down.
Yeah, go way, way down. Yeah. Amazing spark gap. Yeah, got to go quite a ways down. You'll see it. Yeah, click on community. Scroll down.
I'm in the community page. You got a lot of stuff here, Mikey.
Yeah, scroll right down, pretty far down. You'll see pictures of it. scroll down over there. It's about 3/4 of the way down. You gotta go pretty far. You gotta go faster.
Your page is loaded.
Yeah.
Okay, hold on. I'm just gonna spark. If I search here, will it stay on your page? Or-
Yeah, it should.
Yeah. But that's not your page. Go somewhere else. There's no way to search just on your channel.
You can't scroll down here on the.
I am scrolling down. You don't see it?
I don't
No, we don't see it. It's been looking at it, just has Faraday research on top and
Yeah.
Oh, that's
shows all-
StreamYard. Let me
there,
read it.
now we see all four of us.
Hold on a second.
Not everybody can go there and look. And just scroll down about 3/4 of the way down. You'll see it. Those like spark gap.
We know what we're looking for. We've seen the part we need to look for. Looks like a little pill drop.
Yeah.
Am I too far down?
Keep going. Keep going.
I gotta go for like 20 minutes, but I'll be back if you guys are still on.
Ah.
Ah, there it is.
There it is. I'm gonna say you can see the dot.
Oh, look at that. That is blue.
Yeah. Awesome. Awesome color.
That reminds me of the wine glasses.
That is pretty.
Oh,
Did I ever
this
show
is-
the?
In the dark, it looks just mesmerizing.
Did you ever look at the coiled wine glasses, Mike? Did I share that video with you?
Yeah, I saw that. That was pretty interesting there. How did you get the glass to work?
I coiled the wine glasses.
But the
No,
the
that's
glass
all-
itself
that's
is
all-
going-
No, you're not listening to me. The coil was on the wine glass. There was nothing
Yeah, I
connecting to
really-
the coil. There was nothing connecting to those coils on the wine glass. The
I know
coil
that.
started at the stem and went right up to the top as far as I could on the glass, and then the wire terminated.
Yeah, because
There
they're
was nothing
flat like
connected
the
to the wine
dielectric.
glass.
Yeah, you're using the
I
glass.
know that. I'm well aware of that. That's why I'm asking you. How did you get the arc to go across the glass?
Dielectric.
The same way you use a Leyden jar. The exact same way you use a Leyden jar.
Right.
Except for I was getting so if I had a spark originally that far with that transformer, that was my original spark, I could get an air gap like that, right? With those wine glasses, I had an air gap that was more than that. So can you explain that one to me? Oops.
Not really. I mean, that's a high. You need a high potential to jump like that.
That was the output of the that was the output of the transformer, and that was the output of my.
So
I would
what's
say
happening?
impulsive reverse flyback has got more potential to do such a jump like that. It's got
I think what's
impulsive-
happening, you're creating a static potential that's going through that dielectric, right? And especially if you're using high voltage, you can create that differential between dielectric and conductor. And as soon as you create enough saturation between the dielectric and that conductor, it will basically transfer itself from one side to the other. That kind of in the same aspect like a capacitor plate, right? You charge one side of the plate, the other side eventually is going to have so much saturation between that gap, that space in between the two plates. Well, you're ionizing that energy in between the two plates. When you get it high enough, it jumps the gap. That's when you get that transfer over from one side to the other.
All I know is it was
Well,
actually
what's jumping the gap here? What's jumping the gap? Forward voltage or reverse voltage?
Static. It's a static. So it's static.
But see,
A standing wave.
I've seen that same kind of like blue glow, like he's got on his little military spark gap. I've seen that on switches before, on my magnetic reed switches. I've seen that same glow, and it's usually
Doesn't last long, though.
what do you mean it doesn't last long?
I mean, that'll go on for less than a minute. And then
I
the
think
switch
it's
will
a lot.
glow or
No, it was only in one arrangement I could get them to like glow like that. And it wasn't all of the switches were glowing like that, just one of the switches were glowing like that, and I can't remember if it was the positive or the negative. And since that's the positive glowing on that one, right? Right, Mike?
Yeah, the middle prong is positive.
Positive? Yeah. So, and it was weird because you could actually see the magnetic spiral on the reed switch. You could actually see the current being twisted around the reed. I don't know how to explain it. It wasn't like in the contact point, but it was like from the contact point to the end of the tube. You know what I mean?
Yeah,
on the
you're
switch.
saturating. Yeah, you're probably like saturating that space. That space.
I don't know. It was just that same kind of weird blue glow.
Well, here's why.
Yeah.
You asked me to explain something. I got something for you. You just rang a bell in the head. Magneticus. You said tube, right?
What about tube?
So you said it was the glass was a tube, the glass tube, right? That was shaped.
Oh,
like
the
that
xenon
curve.
tube. Yeah, it was illuminating the xenon gas for whatever reason. I don't know why it was doing it, but it was doing it. It was kind of cool. And like I
No,
So
said,
you're
you-
talking about, how did you get the spark out across the glass bottle? Right? That's what you're asking me to explain.
it wasn't across. It was not across the glass bottle. It was only across one side. You got your two reeds inside of there making contact. It was only on one reed from the contact point to the end of the tube. just like half the tube was like illuminated, and you could see
Oh, okay.
that bluish arc was actually twisting around the reed. You could actually
Instead
see
of going
it.
to where you wanted
Instead
it to
of
go,
going in a
that's why the
straight
space was
line.
going through the-
Instead of going in a straight line, it was actually being twisted around. You know, like it was like a real slow turn, like rifling of a gun barrel.
If you
Oh, that
have a
was,
magnetic field right nearby, it might do that.
Yeah, if there's
Well,
a
there was no
magnetic field,
But I was just saying, is it only illuminated half the reed, you know, one side of the reed, and then it was
And the
it
arc
was
wasn't contacting the other side? Sure, we're just contacting the glass part?
it was just like riding around the outside of the metal, just like what it's doing in his. You can see it like how it's flowing around the metal. I've seen that I don't know how many times, even playing with like high voltage and stuff. It's like if you take a copper wire and put a hard 90-degree angle in it, right? And if you turn off the lights and it's really dark, you can actually see the arcs like flying off that 90-degree corner. Like they can't make the corner on the wire, so they just keep going straight off the wire.
Oh, right, I see what you're getting at.
It's
Makes no
I don't know.
sense.
It's like hard to explain it unless you're looking at it. You know, when you're looking at it, you're like,
saying,
oh,
it's like
that's-
saying that the electron has momentum, that it in a direction, that it's not so easy to change that momentum.
well, like Edward Cullen said, you know, the magnets go through the air, just like the electricity will go through the air. And if you give the magnets a conductor, you know, iron wires, copper, or they won't really want to go on copper wires, but you get what I'm saying. They'll hang out through the better conductor. The copper's a better
Right.
conductor than
Least path of least resistance.
right. And that's where I started playing around with the coils and stuff too. Is like the wine glasses, you can actually, if I put water in there and then just leave one of the leads just hanging over the center of the glass, and not where I'll make a gap, you know, won't jump the gap, but you can definitely hear it humming, and everything inside the glass will start spinning the same direction of the coil on the glass. So, and that's why I was like, but I wasn't expecting, you know, the radial arcs in every direction. You know what I mean?
Well, was there salt involved here in the glass? Or
No, it was air, just plain old air.
air? Crazy. Well, when you get to a high enough voltage, you don't need it. You don't need an electrolyte, man. It's the air is smoke.
that's right.
But what I'm trying to say, what I was trying to say is the output of that transformer would only jump a small gap. It wasn't until I put it with that one coil configuration that I got those massive arcing in every direction. You know what I mean? I don't remember if I did send you the link to it, right? Like the video was
No, I
like
saw
dark.
that. It was the glass was arcing at the bottom of the bottle, right? Around the circle part.
Yeah, like it looked like a blue eyeball
Oh,
right in the middle.
I saw that. Just like you see here. Yeah.
And yeah,
That was
exactly.
weird.
Except for those radial arcs in every direction,
And it's
reaching
just
out to the glass.
It's not a conductor.
I had a coil sitting inside the glass on top of a marble, a glass marble or a rock ball or whatever. And then I had that would jump across a gap. There's a gap between that coil and the transformer.
Well, you know what it sounds like to me? Like the coil, if it was oscillating inside the glass, then it made the glass its biosphere.
And if you're watching, I was ringing the Tesla coil with it. Because my Tesla coil was just hooked up to the ground all over the place. And I was getting spark off my top load. So,
Well, these
That's-
sparks are not just doing forward voltage. That's probably not even your voltage creating these arcs. You know?
all I know is I was reading about Edward Lee's calling, ringing the bells, and I kept thinking about that bell shape, and I kept looking at that bell shape, and I kept going, okay, so the bottom of this coil is a high frequency coil, and the top of the coil is a low frequency coil. Interesting, so I have a broadband coil.
Right. That's true. Right.
Because
That's I didn't think of it that way.
The stem is here, and the top is here,
Yeah, the
you
low
know?
frequency is at the white part, and the high frequency. Right. That's true.
And
That's
when you
very
get
true.
the,
That's so
and
true.
when you-
So
and when
can
you
do a
remember that
frequency
way-
sweep with the bell.
and when you remember it's this, and this, there's your electricity, there's your magnetism, and when you get them together,
That's my point about the glass bottle. It was also shaped like a bell, and it has angles.
just
And
like those.
electrical energy likes to flow on angles of geometry angles, like real mass. The curve of the mass. If you hang an electrical wire at the right angle, you know, the electricity is going to flow a lot easier through that angle. 45 degrees, whatever it is.
You got to start experimenting with the transducers, barium titanate transducers. You'll see some amazing effects.
I was looking for barium titanate. Is it barium ferrite or
No, barium
Barium
titanate.
oh the Piezo thing? Okay.
Yes.
Piezo.
Yeah. Start experimenting with it. You're going to see some amazing things happen.
Maybe there's a relation to the barium ferrite magnet. It quite speaks the whole thing. Barium, maybe it's highly piezoelectric.
Well, it rings the bell. It puts it into harmonic resonance. Whatever
You're
that
talking
coil
about
is.
barium already
Secondly-
has its own frequency. When you think about it, every metal does. It already has a set frequency. You can't change that.
Right, exactly. So, guys, you can change the frequency and the harmonic resonance of the coil using the transducer.
This is what you're talking about, right? These things?
When you say transducer, what are we doing when we transduce something? Specifically, what is one doing when they transduce?
It's the piezoelectric effect.
Is it transform or convert or are you converting?
It creates no, it creates a frequency. It's like a Casimir. Right? Like a Casimir, you got that little gap, and the ether pushes the two plates together. Transducer creating the frequency.
Oh, right, because the plates are a certain gap, that already dictates your frequency, or at least it holds it steady with whatever voltage you apply to it.
Yeah.
I see. So it's converting voltage into frequency.
Yeah.
Pressure.
Basically.
It's transducing pressure into vibration. There you go.
Right. That's why they use
the
them
kind
in
of
those.
stuff I like to do.
And while they
Yeah.
use them in the ultrasonic cleaners. They use those transducers to clean components, electronic components. You can buy them on
Because
Amazon.
it's a high frequency.
That's right. My transducers
Right.
resonate at 41 kilocycles.
Like if I was to take my big old swing hammer and run it at like those crazy high frequencies, my coil's gonna burn up because that large area
Okay,
can't
so-
move at that high frequency.
So talk about pressure here and voltage. In what comparison do we see your forward voltage to the reverse voltage in regards to pressure?
Here's a transducer. Barium tight. This is a wafer one. So
Yeah, that's what I was going. Those little things. Yeah. Yeah.
barium close.
That's a big ass one. That's a big
This
ass
one's,
one.
Now, those
almost
things
2
used to be in those
inch
little toys. I can't remember what they were. But
Well, this one's the large version. This one's the barium tight. This is the good one.
That's how we make a mistake.
They're amazing. You hit high voltage into those suckers. Watch what happens. Just watch. Yeah.
well, they can handle high voltage. You're saying low current.
Oh yeah. Oh yeah. I hammer 100 volts in this thing, and the thing just loves it.
DC volts.
Yeah.
How are you limiting the current going into it with a coil?
Not really limiting it at all. I let it do its thing.
Oh, because it has it's not really
Why-
a connection of anything.
I put it in parallel with the coil, right? So when
It's
I
more
put
like
it
a
in parallel-
capacitor. That transducer doesn't. It's not like it's
Well,
closing any switch. It's an
No,
open
it's
circuit.
not. It's not a capacitor. It's like hard to explain. It's like when you apply power, the two plates want to push together, and then when you release
But
it,
they never
come-
touch. They never do touch. Or do they?
They don't have to touch. They don't have to
But
touch.
they never do either, and that's what I'm saying. It never closes the circuit.
That was my understanding. Is it's like the electrostatic charge causes it to like vibrate.
Right. But
Right.
it never closes the circuit. It never shorts.
Well, no, it can't. It can't because they're not.
That's
completely
what's strange to me. You know, like we're not
I-
talking like that.
No, it's vibrating. Like I like to. Okay,
Vibrating
so
without
let's
ever
put
touching. The two plates are never touching each other yet. It's
Well,
still
let's-
vibrating.
that transducer off my little Renegade device, and say I got a sore knee. My knee is killing me. I put that transducer at rest right on top of my knee. Let it sit there for 15 minutes. Pain is gone. Pain disappeared.
Yeah.
And this is what Tesla was doing. As vacuum tubes. I was doing the same thing with the transducer. So I'm finding some healing effects with this transducer against the body. Like a sore knee or ankle or whatever, just set it. It'll actually start arcing on the magnet. It'll feel like little pins and needles. But you just set it on there.
You ever grab the two ends of the BDD pulse charger? You know, the battery terminal ends with your two hands?
Or on the device?
Yeah, I've done that. I used to hold it for like over a minute or two.
Well, I do it with the transducer.
I would feel the pulse go all the way down to my feet, dog. I was like, yeah.
Oh,
Did you lick your fingers first?
It was awesome. I don't know if I did any
Oh.
damage or not, but
no, I do
Maybe
that with the transducer. I do it with the transducer. It just tingles. It feels like little pins and needles.
no, this
right?
thing didn't tingle. This thing, the Bedini pulse charger for the spec, build, you put the positive on either hand and the negative on either hand. The harder you squeeze them, the further down the pulse goes to your feet, to the ground. And I think I was barefoot when I did it. And yeah, I was getting past my arms, down my legs. You just have to squeeze harder or
Like your
finger.
Yeah.
Yeah,
hit
but I
your
wasn't
finger.
feeling like out of control, like I couldn't let go or anything. But I had full control of it. But it's just weird.
I only met two people that could handle passing it from the left hand to the right hand.
People freak
Two.
out. It's a shock
They
factor, like a mental shock. It's not really a physical shock, like until after at least 5 or 6 or 10 seconds, then you're going to get damage from like a standard high voltage,
It's a
high
very
amperage.
immediate awakening.
But that Bedini low voltage pulse, that's not going to. I don't think it can damage anything. Because you're talking 50 milliamps here.
You know how I found out about it myself the first time? I wasn't even looking for it.
Yeah, you told me.
Yeah, finding that PMH inside of a dishwasher, and I was trying to do the perpetual motion holder thing with the keeper on it. And when I connected the power, I had my fingers on both prongs, and that one tap of power shocked the crap out of me. I was like, "What the heck?" I was like, "Okay." And then sometimes it would do it, and sometimes it wouldn't. And then I realized the moisture on your fingers made a big difference.
Yeah.
So I had a 15 kilovolt.
Good shoes also help, and don't let your waist touch the corner when you're reaching in there. You can stick your hand right in there. Don't touch nothing else. And keep your feet on insulated shoes. And don't put your hand on the counter. The other hand. Just one hand going in there with the wires. I'm talking live. And because the hot will hit one finger, the other finger may be grounded on the same hand, but the distance it has to travel is so short that you won't feel a damn thing. It just doesn't go through your body. It goes through your hand, and it does, really goes to the outside of your hand.
Yeah, that's why we did take the right hand. Left hand, right.
You don't feel it till your other hand or your other limb is grounded.
Yep.
or another major part of your body that's got at least more than a foot away distance between the two connections.
That's what got me into cutting the rocks with electricity too. Got thinking about that.
Yeah, I never thought of doing it with electricity. That's interesting though, because you could definitely do it with electricity.
Well, I showed you my new contraption, right?
Yeah, I see where you're going with this thing now. This whole sparks on the circles.
Yeah. So this would be well, except for I made it with string, but you can see there's this is where they attach. So this would actually make the magnetic field, and like I said, I fill the bottle. Can you see the water and sand right there? That's all water, and that's all sand.
And you concentrate the flux into the higher conductive area.
So I turn this upside down. I can heat up this bottleneck, right here. Just heat it up, and then put some wax on there and stick a card on there, right? Piece of paper. Boom. And then I can flip it back upside down, and that piece of wax paper will hold all that inside there. And then I can set this down on my rock, and as I start working back and forth, it'll make its hole, and then the water can only come out to around the bottle.
This is like advanced layman technology.
Primitive tools. That's what Edward said. He used primitive.
You can tell by the way they're using wax to seal the bottle and all that. It's like advanced layman technology. It's very simple concepts that are foolproof, And once you go that direction, it's gonna work, So the sand in the water, is the water salty or is it just sand and water? Or is there a conductor in the water?
So
do you have electrolyte in the water?
If this was copper wire instead of string, it'd be conductive to this point right here, where that line comes to this line right here. And now this would be an insulator. So given the choices of jumping across this big insulator from here to here, or going through this glass bottle down to here, where do you think the current's going to go? It's going to go right down here to your ground rod.
Right, that's what I'm saying. I totally realize that now, because you got the sand and the water in there, and you got the water in there. That's why. The water is going to drip out slowly through the wax paper at a slow rate, right?
No,
right, to where it's supposed to conduct the electrical.
The rock is going to eat that paper in about 2 seconds is what's going to happen. About 2 or 3 turns, and that glass bottle with all the weight pushing down on that paper is just going to rip that paper to shreds. Wax and all.
A little bit of water.
Now you got to remember the wax will float on the water. The rock isn't waxed at all. The water is going to come down into the rock, make a puddle, and the water will push the sand out the bottom of the bottle. And that's what will make your dam. And then if you use that
the wax stand.
No, I'm saying the wax sticks to the bottle, and then so there's your
the sand makes the dam.
Yeah, the sand will make the dam out here, and then like I said, you got your sand pushing down by the water. If the heat of the friction of the sand and the bottle and the rock gets percolated back up into the bottle.
Right, convection.
And then and then it keeps itself cool. The wax floats on the water, so the bottle is technically floating on the rock. The abrasive is getting out in between, and then it will stay there until it gets so small that the heavier sand pushes it out and replaces it while it's digging through the rock. But at the same time, you got to remember that your positive is attached to the bottle. It's going to come down through here, and if you're going to go this way, you put your ground rod right there, and that electrical current is going to keep traveling through here that whole time you're drilling right here, which will give you your little electrical spark, but it'll be underwater. Like I said, produces steam, pushes it out. You get more abrasive.
Steam pushes keeps the
I got a question.
Pressure from being too much on the rock or something.
The pressure.
The pressure balanced on the rock or something, so it doesn't break the cutting.
what I'm trying to say is that the weight, all the weight on this frame up there, the wooden frame, rocks. When the weight is up here, all the weight comes up. There's next to no pressure on that bottleneck, or there's very little pressure on the bottleneck. When they all come back down right into here, that's when they're going to have their maximum pull, and they're really going to push hard on that bottle. And I can tell you right now, you can put 400 or 500 pounds on that bottle, and it won't break from the pressure. But the problem is how would you hold the bottle perfectly still while turning it back and forth? You know, getting it to rock
So
back and
ultimately,
forth.
what are you trying to actually?
Cut the rock.
Drilling rocks with glass bottles, that's what I'm trying to accomplish.
See, he's saying that's how the Egyptians did it. They
Hold on,
didn't have
just-
these machines to, you know,
I'll be right back.
and all that, you know. They had just basic stuff laying around: sand, water. They were still drilling holes.
I think sound frequency was a big part of the technology back then. I think Tesla was onto that. Tesla was experimenting a lot with quartz crystal in his late 70s. So he's seeing a lot of importance of quartz crystals.
Is there any quartz in Egypt? I mean,
Well, they did some experiments. I forget the name of the engineer scientist that was doing it.
they had to go far for that stuff.
They were using granite and also limestone. Apparently, limestone is incredible dielectric.
Can you see that?
Yeah.
You see that?
Yeah.
Can you see them?
So, what do you
That's
think Edwin
pretty
Scallon? What do you think Edwin Scallon was doing?
This is what I think he was doing. All these fit back together like a puzzle piece. If you can figure out which one went where. No. Yeah,
So,
one
as far
went
as
right.
moving stones, how was Scallon's doing it? Frequency? Or?
I think a lot of it was just leverage. To be honest, I think a lot of it was just simple leverage.
Yeah, if there was any advanced technology back then, only the elites had it, just like now. But they still had advanced technology for the regular, and this is it.
Because if you looked at my old water clocks, I used
You know,
leverage.
There was a lot of people building pyramids, you know, right? Like,
All over the world.
well, yeah,
All
all over the world.
over-
So, you know, you
Look at all
can't
those-
find advanced technology all over the world. I mean, that's, you're talking about diamonds. You need diamonds to cut that kind of rock. At least,
Yeah, I was. A lot of people don't know, but in Bosnia,
I mean, this looks like a system that you could set up and just, you know, in a matter of a day, and just get it running and come back in a few weeks and still get done what you could have gotten done today in a few hours or days, you know?
I think that's how he did it. Stuff like that, right there.
Leverage.
No, do you see how I have the block held onto?
You know, they did say that some people said they saw him, you know, floating rocks one night
Ah,
around his thing. It's gone. Besides cutting, if they weren't pouring those big blocks, they had to have had ways to lift them. That was, of course, you could do it like we described here with all the hooks and ropes and lots of people.
you know the funniest thing I laugh about all of them is this right here. Is they say wood rollers, and I sit there and I go, well, when you cut a hole in a rock, you get this thing called a bore core. And if you just take the bore core, get what I'm saying? Oh, oh.
What is that?
It's a piece of granite
Granite.
that's been water jetted. This is the size of a water jet hole. Came in and then went around through.
I'm a water jet machinist. I use the Omax system.
Oh shoot! I got a piece of water on the screen.
You think the
Uh-oh.
Egyptians were working with conductive coils and things like that?
I'm pretty sure they were.
course.
They got them drawn all over the place. They got 'em
So,
drawn all over the place.
you know, they had ways of creating small levels of energy back then. They didn't have no ways of like nuclear power and stuff like today. So they definitely had to, you know, have
You know what
other
that
ways
does?
of tapping into the magnetic field with their low energy pulses, you know.
You know what
That's
that
the
does?
whole
Don't
concept between over unity is you got to use electromagnetism to stimulate gravitomagnetism, gravitomagnetism.
What happens when you do that? What happens when you do that?
When you get gravitomagnetism to flow into your circuit, then you have to transduce it somehow. And that's where the extra energy comes from the gravitomagnetic field, not the electromagnetic field. But you can create an electromagnetic field to attract the gravitomagnetic field. That's the whole concept behind how is this possible? There you go, I just answered it. The gravitomagnetic field is not something that your circuit is, or that your energy, your forward voltage is creating. Now, if anything, maybe the flyback voltage may have some gravitomagnetic coming in with it, you know, because that's not coming from your source power. That's not, that's not forward voltage, it's reverse voltage. And reverse voltage does not happen when the switch is closed. It only happens when your circuit is open.
So that was the cool thing I realized about cutting the rocks with electricity. Is it fit right back to the way. See that?
Mm-hmm.
That's the 4 pieces put back together. And all I did was electrify the bond of the rock with electricity and water. That's all I used, plain tap water. Plain tap water.
Snap like that?
And it snapped right along the line. I put a line this way, I put a line that way.
It looks like a concussion field from the pulse. Was it a pulse?
And like I said, it was those white marks right there. Boom. See those white marks right there? Those little fingers? Yeah, they're like white in there. And when I showed somebody that,
it's a good way to mine for minerals if you're doing there.
when I showed somebody that, how it made these white little fingers in the stone, that's when they said, you need to check out Edward Lee Scullin down in Coral Castle. And I was like, what? And they showed me these blocks that had these bright white marks on them, and I'm like, oh, that's why they want me to look. You know what I mean? So that's why I was like pointing that out is, you know, that was just plain old water, like out of the tap water, you know, there was nothing special about the water. And then I got thinking about, when I was playing with oxyacetylene torches when I was younger, and I was sitting there heating up a spot in the concrete and got told not to do it because the concrete could just explode, you know? So, and I was like, I wonder if the water's just like getting in there and it's heating up and exploding or whatever. And then of course, the more I played around, that's when I started realizing the HHO and the other aspects of it, you know what I mean?
You know, thermal energy is also like electricity. If you heat up a rock, go into
the rock.
Temperature change, it'll explode.
Exactly. So
I mean, an electrical high voltage pulse through a rock would create a heat differential that's so quick, even though it's small, but it's so fast.
So even though you don't see it going through the water, it's happening, you know. That's what I was saying, from the positive to the negative, you'll get that.
Rock has conductive layers in it already that are perfect for the flow, you know. And that's where the heat's going to happen too.
Like I said, as you get your boreholes made, so you can pop them with wedges, you know what I mean? You're making that fracture along the rock with the current, you know, to your next hole, you know. So it's like you just keep going.
Suppose the Egyptians were sending the current to cut these rocks, other than the drill method, but actually here is the cut method, you know.
Okay, well, back to, as much as people don't like the theory that, you know, ancient people had hot air balloons and kites, you know, and they could actually survey the ground, you know, for like the Nazca lines by using a balloon tethered to the ground or a kite tethered to the ground. What do you think happens if I tether a kite to my glass bottle instead of, you get what I'm saying? Benjamin Franklin's key on the end of a kite string.
So you're saying they cut these rocks like that? That's a good one. I can't deny that a possibility.
I mean, if you look at the voltage difference between 100
they
feet
were using
up,
lightning. They're waiting for lightning to do it. The job for them. They just waited for lightning to strike.
What Benjamin Franklin and many others have shown over the years is that there is a high voltage potential charge in the air. It doesn't like to go through the air, so if you give it a conductor, you know, like a wet kite string is a better conductor than a dry kite string. That's how I got taught to check electric fences. You grab a dry piece of straw and touch the fence, and if you don't get nailed, you know it's not hot. Or you can touch it with a green wire and you're going to get, or a green piece of hay, and you're going to find that it's going to nail you pretty good. Because it's only like 10,000 volts on an electric fence or something like that.
Yeah, but what amps? Volts don't matter until you actually can supply the current. You have a dead battery.
The volts are enough to get your attention. That's all they're supposed to do, is cause an involuntary response from your strong system versus the weak system. Just like in your jaw, in your arms, in your legs, you have a strong system and you have a weak system. On your arms, the biceps are the strong system and the triceps are the weak system. Right?
I'm
Top
not
of your arm,
that.
the bottom of the arm.
I got all that. I don't know what the difference is.
You still there?
Yes, sir.
Am I still there? Oh, okay. Well, it's doing the weird static thing.
So, what's your thoughts on the reverse flyback?
I told you, when somebody told me my flywheel was an over unity device, I was having a hard time believing that I was getting 400% out of what I was putting into it. But like I said, there was like, you could see the energy. Like I said, I could tell when people were around because the energy was bouncing off of them and make my switch act funny. I don't know why I did it. I just accepted it was just something that happened. At
Did
release
you
column.
utilize any high voltage diodes to capture the flyback?
Yeah, that's what I told you. I was using 2 kV ones.
Okay.
2
You
kV
dumped
at a
it into
quarter.
what, a battery, or we just used it right
Capacitors.
away?
I just dumped them into capacitors. That's
And
how I
then
got my
what'd you
12 volts. Nothing.
You used it again.
Ran things wirelessly with it. I mean, that was the only thing I could find to do with it. And then the only problem with that is I had the FCC coming after me. So,
How the hell are
Interesting.
they even sent to determine if you're using it?
how?
Yeah, it's just
Well,
it happens everywhere in all kinds of equipment.
Well, unfortunately, that switch makes a very distinct sound. Like ching, 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 ching on the radio. This is what they were hearing, all right?
Oh,
Now you
okay,
have to-
that's right. It's
you have-
interfering with their the radio.
Now-
Gotcha.
Yes, I was causing interference on the local AM station, which was a very popular
Nice.
station. And so they were getting complaints of interference on the radios all around my neighborhood. They were. I wasn't getting the complaints. They were. The FCC was getting the complaints. And one day, like I said, I could always tell when somebody was around. I went outside and looked, and guess who was standing out there with a big old portable
yeah.
antenna, waving their arms side to side, trying to figure out
There
where
you go.
the signal's coming
How does,
from.
how does a signal interfere with such a powerful AM signal? You're just producing a low power signal there. But yet
Like
it's
I-
interfering with all kinds of other signals that are coming from high power signals. And that's because it's a flyback signal. It's not anything to do with the forward signals of the radio stations. It's a reverse signal.
Like I said,
No
I
matter
was
which way you slice it, it's a reverse
I
signal.
was pretty much jamming everything in the neighborhood in that frequency range. And
That's
because
what
I
a
was,
Tesla switch does. Reverse signal generated. Any
And that's
switch
pretty
does that.
that's pretty much when I got told to cease and desist because, and I had to drop my transmitter down to, it was around my house, but that was about
You
it.
had it up high?
Huh?
You had your transmitter up high?
No. My transmitter, well, it wasn't actually intended as a transmitter, but it was just sitting there. But what it would do is anything metal around, it would irradiate. It was like if you put your portable AM radio by anything metal in my neighborhood, you would hear my wheel running. It was everywhere in the neighborhood.
Believe it or not, the Bodini ESG does the same thing, and it's utilizing flyback pulse, and that's what you're hearing in the radio.
And that's what I tell people. It's like, you got to put it in the cage. If you don't put it in the cage,
Yeah.
you're gonna get in
Getting a miniature EMP.
You think that's bad for to be around a pulse motor doing that all the time?
I'm saying if you don't want to get in trouble for causing interference on the radio, put a cage around it. That's all I'm saying. And, I thought my building made of bricks and rebar would be enough to stop the signal, but apparently not. It was literally carrying on all the guy wires in the neighborhood. Like the ground wire on the power grid is what was distributing my
Yeah, that's
My
it.
signal
Think
to
in
the whole
terms of
neighborhood.
vibration. Think in terms of vibration.
I
You're not
was
going to stop the
thinking in terms of
vibrational
vibration.
wave, no matter if it continues to vibrate. It's going to saturate. No matter what the material is. You there?
Yeah. No,
Yeah, it's a Tesla. Think in terms of vibration. You got an oscillator running inside your house, surrounded by rebar and concrete. Which you're right. That's a technical third use. But if those oscillations keep on going, everything's going to eventually pick up on the same vibration.
Well, you said that it was connected to a ground, right? Well, ground systems today are not isolated. They're part of a network of grounds.
That's correct. They
So
all
every
go to ground.
time-
They also go to
every
the
time-
common of the grid.
well,
Right,
this
so-
is why they had a hard time triangulating me, because my transmitter was sitting at the intersection of 3 ground wires. 12,000 volt ground wires at that. So, but the funny thing was, I let them get about half a block away from me, still, where I could still see them. And when I unplugged my device, you should have seen the look on their faces as they just started going like, "Which way did he go, George? Which way did he go?" Because they realized I was watching them, and and it was just kind of like,
If you had, say, like an iron rod and you hammered it into the backyard, 2
Mhm.
feet into the ground, you probably would have been okay. But if you hooked it up to a common ground system that's part of the electrical grid,
Right.
you're just ringing it through everybody's house,
It's
basically.
on that grid.
Yeah,
I was-
anything that's on that
Not
grid.
only that, you're ringing the grid to your ground, and not to its own ground. at least you're ringing the grid to your
Common
ground at
ground.
your frequency, as well. The grid is going to ring itself to its other grounds at its frequency.
Right, because it's common ground.
Right.
That white wire, the white wire in the wall where your receptacle is, that's called a common ground.
You can transmit Ethernet digital packets through your electrical wires using carrier.
The ground wire, because it's common ground, it's connected to everybody. It's not an isolated ground. It's completely different. The white wire that's in the receptacle box in your house where you plug your stuff into, there's a green wire, black wire, and a white wire. That white wire is your common ground. So
I understand the grid didn't used to use their own ground. They used to use the Earth's ground.
that's right, but they don't do that today, and that's what Eric Dollard was
Now
talking
they
about.
take your energy and recycle it and sell it back to you.
That's right. Scam. Big time.
And they do it through the common ground that they send
Yeah,
back.
it's a loop system. It's a loop. It's a closed system, not an open system.
You got to remember, they're all about tax revenue.
Right.
It's all about using electricity, not everybody having free electricity.
Well, Dollard calls it electromagnetic terrorist weapon.
Well, you know, it's like I was on Mr. Rob G's social dig the other night, talking about the gasoline, and it's like I've known so many people that track their mileage, and they couldn't tell you why they get less gas mileage in the winter than the summertime. They just can't tell you. They can show you on paper there's a difference in gas mileage, but they couldn't tell you why. You know why, right? Phillips 66, Union 76. That's why. Nobody made
Temperature,
connections.
shrinks your gas. So.
Yeah, exactly. So you got less, and the colder, it's like gasoline
Does the
gets
same thing to
more.
your own body too, actually. Does the same thing to water, probably.
Well, water expands when it gets cold.
Well, no, that's converting to ice, and there's air pockets in this. But the actual H2O is probably shrinking.
Like I
while
said,
it's
the
creating air pockets.
it increases volume when it gets cold, and oil decreases volume when it gets colder. So if you measure the same amount of fuel, well, actually there's more air in the wintertime too because of colder air.
Yeah.
And it uses more fuel because there's more air, and the O2 sensor doesn't say whatever it's supposed to say. And we were talking about that too, how they went to electronic injectors because putting moonshine in the motor fuel was causing all sorts of problems with carburetors, with only carburetor. That's why only, push mowers and stuff like that have problems with ethanol gasoline anymore. But if you just empty the float bowls at the end of the year, you don't have a problem, So, but yeah, it's just funny. Same with Tesla, is because it couldn't put a tax meter on it. Couldn't put a tax meter on somebody with a coil of wire picking up the frequency that's being emitted, And that's the same with the diodes and the wireless energy. You got to have your antenna with a pair of diodes running both directions to a pair of capacitors to whatever you're using as a load. You ever done that one? And people are like, how's that work? And I was just like, because the wheel is emitting the electromagnetic frequency, and if you got a coil that picks up that electromagnetic frequency, it's like Tesla coils too. Everybody shows the Tesla transmitter, but you don't see anybody using a Tesla receiver. I mean, I think I've seen one person use a Tesla receiver. One person in over 10 years. I've seen tons of people that make a Tesla transmitter, but I haven't seen anybody that uses the Tesla receiver. And then I look at some of these so-called perpetual motion machines and or free energy machines, and I wonder if there's like a Tesla transmitter running in the background somewhere, you know what I mean? And it's just being powered wirelessly, I mean,
Yeah, there's always going to be stuff like that out there, always. I just like my channel, I like to just put ideas in people's heads and then go and do it. Go and experiment for yourself. That's the only way you're going to find out the truth, is by building the stuff for yourself and seeing it before your own eyes with your own ingenuity, and then you can see what is valid and what's not valid, what works and what doesn't, And that's how I start. Go in with a non-biased attitude. Leave your attitude at the door, your ego at the door, and experiment. Don't think you know everything, because you don't. Experiment, and then that's when you learn. And that's how it started. That's how you start. Leave your ego at the door. What you think you know, leave it at the door. You're going to do stuff that goes against all that stuff.
All right.
And
Well, I've already seen that too many times. Done seen that too many times now.
Hey, you know what the Adams motor? What I like about it? It's totally it's just dumping the flyback from the two coils into the other two, and it's like just a perfect setup for driving a motor.
It's a rotating transformer.
It takes in forward voltage on two series coils, 180 degrees apart on your motor, and then it sends out the reverse flyback voltage into the other two coils. On the other two sides of the 180 degrees. Right. It's like, Bing, what the hell, man? They don't make anything like that. They don't make these motors like that, bro. What's wrong with that? That's like 100% efficiency right there, at minimum.
Yep.
They're
don't make
designed.
a motor
They're
like that.
designed to use energy, not save energy.
That's totally a ripoff.
Yeah.
I'm an electrician, man. I put in, let me just be real with you. I put in at least 5,000 switches, 200 breaker panels, and 5,000 feet of all kinds of gauge wire and pipe over the, I don't know, 30 years. I've been doing this since I'm 17. Worked for multiple master electricians. They make tons of money and tons of work. Elevator shafts, pumps, rooms under the ground for huge fountains and stuff like that. And I'm telling you, man, none of this equipment is doing any of this stuff that we're talking about here.
Yeah, because all of it's based on current.
You're talking
regular
about heavy duty equipment.
Yeah.
Just
All the-
guzzling away. I mean, the electric bill on these one elevator shaft. Do you know what that is? I mean, it's like for a 30-story hotel. It's like a couple $1,000s.
A month?
I think so.
Oh yeah,
You know,
drop-
heavy duty motor, unless they upgrade to like a high efficiency permanent magnet DC motor, and even those motors are not operating like the
Okay.
Atom.
Let me ask you this, Mike. You spend $1,000 on electricity. How much of that was taxed?
Well, it's all deductible in your taxes. It's a write-off.
No. The electric company
You
charges
just
you
gotta
tax.
pay it. You know, you just lower your tax that much.
I said in $1,000 of electricity. How much of it wasn't taxed?
Wasn't taxed or was taxed?
If you had a $1,000 electric bill, how much of that $1,000 was in tax? What percentage?
The state, I think, takes a certain tax on the power company. They charge that. It's all rigged up like that. Yeah, I know what you're talking about.
and they charge you more for reactive power as well.
I'm just trying to tell you that they're gonna get you either way. It's all about the tax meter.
Yep.
The
Yeah,
19th
it's
Amendment.
tax
The 19th
Hey,
Amendment.
you
in
know what?
America
I
was
don't
all
need any
about-
more taxes. I pay real property tax, and thank you very much. But I'm good. Nothing else coming this way.
Like I said, there's nothing more than
Quit using electricity if it comes to it.
there's nothing more better than a man in the government goes and says, "Hey, Mike, your house over here, instead of being worth $200,000 in tax revenue, we now deem it as
I'd like to see
$400,000."
them. I'd like to see them stop me from getting on my bicycle electrical generator every day just to make the power I need each day to make my power the old school way. And I did a rhyme for you guys. How about that? I'd like to see them stop me from getting on my bicycle generator every day to make the power I need for my house every day, each day.
You know what I remember from the science center as a kid is
That's control factor you're talking about there.
they had a bicycle attached to a generator or a really big magneto or something. I can't remember which it was, generator, and they had like a whole bunch of 100-watt light bulbs hooked up to it, and it was like hard as hell to try to pedal that alternator, right? So I always wondered what would happen, because if you ever try to spin a big heavy flywheel with a bicycle, it's pretty easy actually. And I was wondering what would happen if you spun up the flywheel, and then when the flywheel got up to a certain RPM, it'd flip on a switch and turn on the generator and put on the load on the generator, and then use the speed of the flywheel. You know what I mean?
Yep.
To turn the generator until it
You know,
gets down to a
if you're
certain
gonna have a
RPM.
bicycle generator, you just want to have a really heavy flywheel on that.
Yep.
Just spin that up first, right?
That's right.
And then connect the load to the generator.
Even, you know, I think there's some tribal people that they have this like the cliff. It's like a 100-foot cliff or whatever. I can't remember where I saw this, but they go up there and they just step on this pad that they give weight to, and it's a rope system, and it spins up the generator as it drops them down. They need to go up there to work anyway because they're farming up there, right? So they don't
Yeah,
want to
gravity generator.
They just come down to this lift, this makeshift thing, elevator thing. I don't remember where I saw this, but yeah, and they're making power with it too
Yeah, gravity generator. Yep.
for their cell
Yeah.
phones and things like that, and light at night, like a couple of light bulbs. Like
Um,
tribal people out in the forest doing their farming and stuff.
Yeah, it's like the pendulum motor or whatever that thing's called, where you drive the crank of the wheel with the
I mean,
pendulum.
they're walking, you know, they weigh what, 150 pounds. They're walking at it themselves up their body up the mountain or the hill, and then they create a rope system and on the edge of it that can lower them down. 150 pounds is a lot of. See, the human body makes a lot more energy for the food it eats compared to the food it eats. The energy it takes in, and you gotta think about that. That's crazy.
Well, it's like Edward Lee Collins hanging bed.
It's over
Think about
unity. You're looking right at it, you know.
Edward Lee Collins hanging chair, hanging bed. Think about it. What you just said.
Yeah, you
Yeah,
gotta have
the
a slow moving gear system to slowly drop yourself just 10 feet over a
And if
period of time.
And if
that
you're
would still
hammering
spin up
away at the
some
rocks, if you're hammering away at rocks and stuff, having a pendulum, keep time with your swings. You know what I mean? That's one thing I noticed too is when you hit the rocks hanging up in the air. Like I was showing the brick being held by the piece of PVC pipe with all the lines across it. If I find the center point, which I could just hook to the two ends of my rod and then go to up above on a pulley. Now I can rock it back and forth. And that's when I got thinking about hitting it from both sides, because he was saying ring the bell twice. You know what I mean? So it's like you hit one side, and that causes the other side to come up as you're coming down with another hammer hitting that side, which knocks the other hammer back up. Just to give you an idea.
Wait, he was shaping the rocks, you're saying? That's how he was shaping the rocks.
All I know is he had big turntables. That's all I'm gonna say. Yeah, really
the
big.
rocks into all kinds of shapes.
Right? State of Florida. How would you increase the size of an image of the state of Florida?
Not sure what you mean. Increase the size of the image of the state of Florida.
If I was going to take a picture of Florida from my geography book, right, and I was going to project it to make it bigger on the ground of where I was cutting, how would you do it?
With a projector or hot air balloon and projector.
There's this little thing looks like a scissor jack kind of, and you can trace one object. You can trace one object at small scale, and the end of the arms will actually draw the shape much bigger than what you're drawing on the paper.
Oh, okay, with the pendulum effect. I got you.
Well, no. It's like those the old look like a scissor jack with like the punching things. You remember those back in the day?
Scissor lift.
Yeah, like remember how they do the gloves on the scissor things? So they come in real close, and then you push the two handles together, and then it would like cause the glove to go and hit somebody.
Rings a bell. I think that's the only talking about.
Yeah, you'll see it in an old cartoon sometime, and you go, oh, that's what he was talking about.
But then again, with leverage, you can rock a long stick at the bottom with some weight and a cutting tool, and cut a rock bigger than you can see from above. You can just swing it from up above. So there's all kinds of ways to cut things. With pendulum.
Oh, I know where it's at. I actually know where this one's at.
But Ed Skelton was making C-shaped objects, like curved objects too, out of rock. How do you do that without a cutting saw of some kind? And even if he had a cutting saw, how do you cut a curve like that? You need
He put it on a turntable. Put it on a turntable, and his hammer could only swing so far.
Oh, okay. And again, with the pendulum hammer.
I saw one time they were cutting rocks using water pressure.
Yeah, you can cut.
Yeah, like the
Well,
like
He didn't have that though.
That's what I was talking about. One of these things. I don't know how to explain it though, but this will like draw things bigger than trying to remember which one's the anchor point. I think that's.
What was those? Ed had some kind of tripod with a box on top. And, there was something in that box, and it was definitely needed to be protected from the weather. So it sounds electrical. Protected from the sun and weather. And when you want to protect a battery, you don't let the sun hit it.
That's what I was talking about. One of those things. So this one is you anchor. I think you anchor here, and then you draw with this one, or you copy with this one, and this one out here makes the bigger image. If I remember correctly.
Well, that tool, right? It's like a real ruler tool.
So I'm debating if you hung a light over a small image in front of a magnifying glass and projected a larger shadow on the ground, or if you used a tool like that to, draw something small or, copy something small and make it bigger.
The shadow thing's an interesting one. That's a possibility. That's
right.
That's like a projection. It's just another way of projecting.
And it usually worked at night, so, that would be a feasible way to do it because, and then once you have your stone marked in chalk or whatever.
So what do you say? He had a light, he had electrical, or he had a battery in that box on top of the tripods, and he had some kind of light coming down from the top to create a shadow from that box. That box was powering his light source for the shadow to make his dimensions larger than from above. What you're saying.
And if you remember how Model T Ford works, it uses a buzz coil. So, if you had a battery running a buzz coil, the buzz coil produces your high voltage spark, which, like I said, if you're cutting rocks and leaving white marks on them like he was, I wonder if he was electrifying the rocks. Hence, they break right on the line. And if they break right on the line, if you put the two rocks back together, butt them back together, you'd have like near seamless joints in the rock. Would you not?
A trembler coil?
Huh?
Is that a trembler coil?
A trembler coil. A buzz coil. They're called buzz coils. And if you look at the old shop manual for the Model T, and you look at the ignition system diagram, you're going to see that same sun and earth drawing or whatever on the iron door. Except for it's not labeled sun and earth or whatever it is, sun and moon or whatever I drew on there with this little lightning bolt thing going across it. I'll find it later for you. I'll send it to you in email. You'll see what I'm talking about. That buzz coil looks like
What
a
is
buzz
that
coil.
sound in the background?
Oh, me?
I don't know.
You
I
hear
hear
that?
something.
You hear this?
Yeah,
hear my
that.
big
What
old-
is that?
My water fountain.
I couldn't like, you know, like I had like 5 different things I was thinking. You know, I thought it was like a video running like forward very fast. You know, like how like you're going fast motion, how you can hear a sound. Like,
Right.
You know. It's
So
like,
yeah, the water comes up through here, tees off. That one spins counterclockwise. This one spins clockwise. This one is designed for pumping air. That's all its only purpose is to pump air. So the water coming down through these 4 comes up through this one, then splits off, and then splits off again, and that causes the air to come up through here and go down in there. And then I stick them down in bottles like that under the water, and then I can get air pressure. So, and I've lifted things with airbags too by pumping the water here. See, like, I don't know if you can see those air bubbles, but they're coming from about 4 or 6 liters down in the bottles. There's like 2 or 3 bottles down there. And then you can see the water building up right here above water, but it's still moving air down below. Same way here, I get a little bit of air bubbles. And then so I'm working on Lord Kelvin's dropper, so you'll have your sprinkle head here, and they'll go through a coil like that, and then it'll go to a screen mesh like that. And then this coil will be attached to that screen, and this coil will be attached to this screen. So, and I should get some high voltage electricity just by the falling water going through there.
oh, that's really cool.
So, yeah. And then that's just kind of like playing around with the oscillation idea, you know, because the coils can make springs. I put the bell on there.
Are you moving that right now?
Yeah, I'm touching the end of it. Just going like that with the,
It keeps the motion pretty well.
yeah, it goes into,
It seems to have a long, lifespan of echo. Hold on. Bring it.
variable resistor. Because when it comes in closer contact, the resistance goes down. If you had one connected here and one connected there. So,
Right.
because then it touches all the way into points in between. Otherwise, it has to go around and around and around.
Do you have neighbors?
That's a great way to make a frequency sweep.
Do I have neighbors? I got neighbors all over the place.
I know, I bet they enjoy that sound.
They think he has cows or something. Probably.
Oh my gosh, the one guy, he was like, I guess he seen like my fishing poles and stuff, and then he seen the cowbell, and apparently wherever he was from, they put cowbells on the boats, so I can tell where the boats are at night. I'm like, that don't fly around here. So, yeah. I have things like that, because my old water clock will pick this up, pick it up, drop it, pick it up, drop it, pick it up, drop it. Oh no, lost one of the cables. Oh.
These are types of, these are physics experiments that you're doing here. You're doing
So that was
physics.
part of the reason that I would do these water towers too, is because I need the head pressure of the water being at a certain height. So I originally would take the tops of the bottles and I'd cut them off like right in here where they make contact, flip them over, and then I'd have this little pool of water that when it overflow, it would just go right down the center. And then I'd always have this constant water line like right there. You know what I mean?
Right. That's the
And then
center of gravity for gravity.
So then I could take something like this, you know what I mean? Which a cup of water is nowhere near the weight of this, but using leverage, I could pick up all that weight with that much water. You know what I mean? So, and then it was
the actual leverage device has weight of its own.
like I said, it's a ton of fun trying to figure out where the balance point is, where it wants to lean like this with the
You have to
heavy
use
weight.
center of gravity to use leverage.
Okay.
Yeah, so that's basically the concept. Center of gravity is the fundamental part of leverage.
You see this puddle right here? Or sticking my finger in that rock? See that hole right there? That was nothing more than an 8-ounce plumb bob being picked up, dropped in there. Boom,
Right,
just like that.
because it was being dropped exactly in the same spot using center of gravity techniques and leverage. You were able
Okay.
to do that. If you hit a different spot, then you're not you're just starting all over.
My automated machine was hitting the same spot over and over again. So if it hits the same spot over and over again, all I have to do is move the workpiece under the hammer and it keeps moving along. You're asking about how he cut the shapes and stuff, and I'm saying he had like the sunbed that you could rotate all sorts of things on there. You know what I mean? And then when it was the blowhole is what got me
how
thinking.
simple these techniques are. It makes you feel like an idiot when you realize how basic it is.
And needless to say, when I took my frame my frame, and you've seen the videos like towards the beginning of this year, where I had springs in here between this cable and this cable, and putting a magnet, an electromagnet, I had it going like that. Bam, 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 bam. You know, and I kept thinking about his pool, his hexagram pool, and I kept looking at that star or magnet of David or whatever, and that's why I started. And I was thinking about the Mason symbols too, using the six-pointed star. And you always think about, you got your plumb, so you always know where your center of gravity is going down that way. And he said you need a sound base, which means it's got to be something solid. So, you know, needless to say, all you got to do is that number 2, and it's only gonna, it can only reach down so far, unless you lower down the legs. And that's when I came up with remember the nifty idea of using like bolts or screw jacks, you know, to control the height. Bottle jacks, whatever.
Yeah. Did you see that homemade reed I made? Necessity is the invention. It's the mother of invention.
That's why I made my reeds too, you know. I couldn't find one on the market that would do the job.
Do what you needed it to do, right? It kept blowing out.
Right. Should we show Faraday Mike the knife trick? And
yeah, that's the weird one, man.
All right.
You know, when you rotate it, before you show it though, let me say this. Any object that follows a magnetic field, you have it aligned 180 degrees, the magnet, and the object follows the 180 degrees, and then you rotate the magnet another 180 degrees. The object should also rotate 180 degrees, right?
Yeah.
But
okay.
That doesn't happen here, guys.
All right.
It rotates 90 degrees.
We're gonna pay attention to the knife here. So see the handle coming down here? That's the sharp edge. This is actually designed to be held like that, right there. And so this is the dull edge.
Like weaponry? Oh my gosh, I'm gonna love what I'm gonna show you.
No. This has nothing to do with the weaponry. I'm just saying that.
I think I know where you're going with that. The curve there.
So that's the center of gravity right there, and the handle. I'm gonna put it on here. Mike knows this trick. I'm gonna take the blade, and we're gonna spin it.
Oh my
That's
god.
gonna take a minute.
So it's just touching a magnet right now.
Oh.
Essentially.
But still.
The magnet is
This isn't
straight.
This isn't the cool part. This isn't the cool part. This is where we gotta wait.
See where it stops.
Watch
Watch where it stops.
Because the nice thing about science is it's repeatable over and over and over again. I was just pointing out the sharp edge from the dull edge, so you know which way the handle's pointing. So if the handle's curved down, you know that's the sharp edge, and if it's going up,
Sure.
that's the dull edge. And we're facing west. That's west right now. That's south and north, and east is behind me. So it's eventually going to come to a stop at like
north and south, right?
Actually, it's going to go like northwest, I think, if I remember correctly.
Wherever the current pole is.
That's like a northwest direction right there, and that's where it wants to stop at. So
the lines of
Do
force
you
are
think
directing.
the effect
Now,
of
now
the
wait, you're
actual-
spinning the magnet thing array there,
now,
right?
now I'm spinning the magnet array, and as you can see, it's not really having much effect on the blade. And if I
Right,
stop it
right.
any random
Okay.
place,
Now watch this, guys. Watch what happens next.
Now-
You're not gonna understand this at all. Guy's gonna
Now-
flip it around the pole of the magnet array.
I got to put this down for just a second because I need both hands to do this. Oh,
He's gonna flip the poles on the magnet array, hanging on the spring there, which is a 180 degree flip.
okay. If you're paying attention,
Turn
there's
it around.
more magnet. I turned it around.
Yeah. The magnet, yeah. You just flipped it around, okay?
I
It
know
should
it's
go
gonna-
northwest. You're thinking it would go northwest again, right?
It's not. It's going to point a different direction.
It's going to point
You
south.
shouldn't be doing that.
And it's kind of hard to put a magnetic compass around here because all these are going north, south, north, south,
It's
north,
still
south.
essentially the same toroidal field, though. You know.
But the pole magnet is north, south, or south, north. I don't know which way it is right now. I could take one magnet off and go put it by the compass and tell you which way it is. Oh, I hate doing this. This kills my back leaning over like that.
This is my
You
little-
remember if the handle was pointing up on the right side? Yeah, right.
You always reverse the video. Always reverse the video.
But it's not going to be facing northwest, is it? No. So that's
You
another
see
thing.
a little experiment?
All I know is the blade aligned this way last time. And this time
Right,
it should be
it's
like
aligned
that.
northwest, right? And this time, it's doing what?
Now it's wanting to go north, south.
It's slightly off or something.
Now it wants to point north, south. Right there.
It should, and within it should be pointing northwest, like before.
But before it was pointing northwest.
Because all you did was flip the magnet array around, and you're just
That's
flipping
all
the
I did.
toroidal field around. It's a toroidal field.
Did nothing
How's
else.
it- how's
And
the
like I
angle
said-
changing a little bit here.
Like I said, you can spin the. Oops.
It's
can
changing
spin it
45 degrees about, right? It's about 45-degree change there.
Yeah, about that, yeah. Because the other way, oops, the other way it was like right here, and then that way it's here.
That's
So,
about
yeah,
45 degrees.
That makes me wonder if that's the North Pole and that's the South Pole. Because if it was the South Pole, it'd be attracted to the North Pole better. And if it was the South Pole, no, I mean if it was the North Pole pointing down, it wants to deflect the North Pole of the Earth.
I mean, to me, it looks like it's facing west now, directly west, not northwest. I mean, the way it was just before he spun it was facing directly west.
Might make
Not
me wonder
northwest at all.
how, but they shouldn't because they're all equally spaced. Try it again. I mean, that's why I've changed, that's why I turned this around too, just because I always thought it was like maybe attracting to one of these magnets or something, but I won't touch it this time. I'll leave it alone.
Have you ever seen an experiment similar to this anywhere else?
Magic shows. That's fun. It's really, really, really cool. Like,
Look, it's lining up west, like before. And then the first time he spun it, it lined up northwest, which is 45 degrees. That's exactly 45 degrees. I know how you use the compass. It's from the scouts forever. Northwest to west is 45 degrees. Or is that incorrect? No, that's 22 degrees.
Yeah, it's just weird that it does that though. I never quite figured it out either, but I just figured it has something to do with I'm closer to the North Pole than the South Pole, and the South Pole magnet is attracted more to the North Pole magnet than the South, and the North Pole repels the North Pole. So,
Plus the two arms are curved, left and right side. One's going up, one's going down.
so that lets you know the pointed edge from the. I don't know. It's weird. I can say that much about it. It's weird.
It should keep the same. It should flip 180 degrees. There should not be a 45-degree change in angle, just because you flip the magnet away. You're talking about a toroidal field here.
All I know is when you're playing with magnet wheels, stick a center magnet under your flywheel. And depending on which pole is pointing up, your flywheel's either going to go faster or slower. I'll tell you that much. And it's just got to be right in the center of it. And that was what I got shown years ago. And I know Edward was being show off with all of his magnets because he was like showing his magnetic chains and, 4-car
You know
wheels.
what I think that chain was doing? The chain that he had wrapped and everything. That chain was connected to, the PMH, the permanent magnet holder that he made?
Yeah.
I think the two ends of that chain was hooked up to that. Like,
You can,
I think he had a bar across the PMH, and he induced the flow, and then he connected the chain, the two ends of the chain, and when he had the chain in place, whatever he was trying to polarize, whatever he was doing with it, he slipped the bar out, and pulled it out with the chain already connected also, so that the field was looking for a place to go, and it's the opposite equal reaction.
well, I always point out lawnmowers and their ignition system. No battery. Where does it come from?
The spark, you mean, to start the engine when you spin the...
Yeah, that's exactly what I'm talking about.
That's a good question. There's no stator in there? You telling me there's no little stator up in there?
Look at the
Or
old-fashioned
dynamo?
ones, not the new ones. Look at the old-fashioned ones, and tell
That's a
me how
good
you get that. And what I tried to
How you
say
get that
is,
spark through the spark plug? How the hell does it? Right, nobody even has that. They just go ahead and pull it and pull the rope.
ask anybody that has a Model T. Anybody that has a Model T, they'll tell you that Model T will run better off the magneto than the batteries. You get a better spark off the magneto than you do off the batteries running the buzz coil. Why do you get a better spark off the magneto than the batteries?
Because the magneto is analog in motion power, whereas otherwise the battery is solid state. That's the difference, I can tell you. But I think momentum is a key here to better spark.
Now think about what Edward did. He didn't use one magneto. He used the parts from 7 magnetos. He had the magnetos from 7 Model T Fords on his flywheel. Now why would he need?
Ed had let me repeat that. Ed had 7 magnetos on a flywheel.
Why didn't he took 7 magnetos from a Model T Ford, 7 Model T Fords, to make one flywheel? Why would he
He
use?
electric for his house and watch TV and whatever.
He wasn't watching TV. He didn't
I
really.
mean, It's just, I mean, definitely for electrical purposes, that's for sure.
And that's what I was saying, is that he was producing a much greater spark than a spark plug. That's what I kept thinking, is all you have to do is hand turn that wheel.
Cutting the
and-
rocks with that high spark, you're saying. Okay.
Exactly.
Was he trying like to produce like plasma energy?
All I
You
know
get
is
that
that
kind of a spark, probably so.
he had coil bubbles all over the place.
Or
The
maybe
coil
like,
bubbles,
to melt something, you know?
I think it was a pulse, though.
but it was an AC signal. His flywheel was AC. It wasn't DC, it was AC.
Didn't you say he had capacitors? Or was that...
He had capacitors around there. He had the jars wrapped in wire too. And that's kind of what got me like trying it out. And then I seen like really weird things, and I was like, okay, there's something weird about, you know, wrapping the jar in tinfoil versus wrapping the jar in wire. You know what I mean? And when I made my homemade capacitors, I used one of those zip tie pullers, and I like was gonna bust the zip tie if I tried to go any tighter with them, and that would increase the capacitance of my capacitors. I knew that much. So then I started wondering, well, maybe because you put the wire under tension when you're going around the bottle, you know, maybe you get that extra, I don't know what you call it, contact or whatever. I don't know how to explain it, but
Okay, well, okay, when you energize the coil, it's going to contract like a snake would. And it grabs something.
well, like I said, you don't. Both ends of the wire are.
You don't
are
see
just
it. The contraction is so small and it's terrible.
That's what I tried to show with the wine glasses, is how there was no. I could go from one wine glass to the other wine glass and show you there is.
So there you
You
go.
know.
If the coil's contracting in such like a nanometer contraction at a certain high frequency, it's going to easily make anything vibrate without destroying it.
But it does
I mean,
destroy.
The
That's the
glass would
thing.
have broke if the
It
copper
does.
wire contracted any more than a nanometer. The glass would have broke.
The glasses would periodically break. I had all sorts
You
of
took too
glass.
much voltage through and you contracted more than a nanometer. You
And-
contracted 2 nanometers.
Well, what I couldn't figure out
Too much.
if I was thermal shocking the glass, or just breaking the bond of the glass.
You were
Like I was
pressure
doing with
fielding the
the-
glass with high pressure voltage pulses. It's
That's
all
what I
pressure
was-
fields.
I think it's the vibration. You're breaking the bond.
So you're vibrating it with pressure fields from voltage.
I know that was one of the things you couldn't see in that video I showed you, was the fact that I was adjusting the variac to change the voltage going to the transformer. And it was only when I got
You were
to certain,
lowering the voltage because you broke the glass.
I had to have to lower the voltage to get it to just like the right amount to where it was just like. Well, you've seen it. It looks like a spark plug jumping in every direction. I mean, it's basically the same idea of a spark plug, you know, because you have like your center tap and
You
then
know,
it,
if the glass wasn't there, you wouldn't have to lower the voltage. There's nothing to compress onto other than air.
if
So
I
it
had the
makes sense
coil,
why air becomes very dielectric for these test coils. You know, it's sufficient because you get to such a high pressure. I don't think it's just the air is being pressurized.
all I know is I'd look at the coils and it reminded me of magnifying glasses, and it was doing the same thing with the electricity. It was like it was magnifying the output of the current. You know what I mean? Instead of just getting a little, you know, maybe quarter inch, half inch,
So you're
whatever.
using a flyback transformer for that. Come on.
I was using a neon sign transformer, 7 kV, like
that's,
1.5 amp draw or something.
It's still high voltage though. That's a high pressure.
Yeah. Yeah, and like I said, it was playing around with those kind of things.
1.5 amp though. At that voltage, you had to have limited the voltage. The amps. It wasn't.
Well, I was
40
using a
amps.
variac. I was using a variac to the input of the transformer.
Oh, what voltage did you have the variac at?
I don't,
60 volts?
I don't, I couldn't tell you.
You had it lower than 120. That's for sure.
I was just using a light dimmer switch, and that's what I was using for a variac, and I just tied it in line with my neon transformer, and I could control the voltage a little bit because I was.
Because once you can't put 120 volts straight into a neon. If you do, you're going to get full brightness, a lot of amps too, and it's dangerous. But you can drop the volts and still keep a relatively high voltage off the neon with low amps, and then it becomes interesting because you don't damage it. And you do all kinds of experiments with devices
All I'm saying
running.
is the arcing is what got my attention. The amount of arcing I was getting, because you got to remember, I didn't have one wine glass coiled. I had a wine glass coiled inside of a wine glass coiled.
Can you put the
So
link
I
in the
had-
chat real quick to that video?
If I
You on your
disappear,
phone?
I'll be right back. Let me see. Can you still hear me? I still hear you. Okay. I'm still there, apparently, so let me go to my YouTube channel, and go my channel, videos.
Link it in the chat.
I'm getting there. I'm getting there. I'm getting there.
So can you buy one of these buzz coils today?
Um,
we have to make one?
Yeah. And you can make them too. You can make them too. Let's see. Boom, boom, boom. Sorry, I'm
It's
like.
basically what, an electromagnet in there? And
Oh, what?
what's inside the buzz coil? Electromagnet?
Oh yeah, it's an electromagnet. And so when the current comes on, it turns on the electromagnet, which opens up the reed switch. And then when the reed switch opens, the reed closes and powers it back on, and it's just opening and closing the switch at a high rate of speed.
So I'm
Depending on
going to
the
read this here. It combines two magnetic devices on the same iron core solenoid. The first is a transformer used to transform low voltage electricity into high voltage, suitable for an engine spark plug. Two coils of wire are wound around an iron core. The primary winding carries the low voltage battery current. Carries the current from the low voltage battery, and the secondary winding generates the high voltage for the spark plug. Basically, basic Tesla coil. Attached to the end of the coil is the interpreter.
Interrupter.
Throw a cardboard box on this the cat. Stop messing around on the table.
Cats are cool.
So it's a Tesla coil. It's a high voltage Tesla coil.
I'm just
the
saying.
coil is an interrupter or trembler.
I'm just saying what
That
you
magnetically
do.
operated switch, which repeatedly breaks the primary current to flux changes in the transformer needed to produce high voltage.
Exactly.
It's a flyback generator. It's a switch creating a.
No. Because what you're doing is, like with me, I turn my flywheel when my electromagnet turns on. That's what's turning my flywheel. But in series with the electromagnet turning the flywheel, I have a high voltage transformer. So not only am I sending 12 volts to my flywheel driver, I'm sending 12 volts to the high voltage transformer at the same time.
And you're stepping up the voltage from there.
Mm-hmm. And you charge up a capacitor. And when you charge up the capacitor, and then your distributor cap goes around and around, and when it makes contact or closes the gap between 4 points on that distributor cap, that's when it fires each plug individually. But they ran 4 coil packs, so each spark plug. So the buzz coil is charging multiple times in that revolution of the distributor cap before it gets back to the
Notice
one.
where it says here, magnetically operated switch, which repeatedly breaks the primary current to create flux changes in the transformer needed to produce the high voltage. That flux change is the back EMF flux, which is directly correlated to the reverse flyback voltage.
Except for you're using it to,
This is implosive. This is an implosive force.
using the magnetic flux. You're using the magnetic flux of the 12 volts going through the primary coil to produce high voltage in the secondary coil.
But reading this, it specifically tells me that they're switching it to create back EMF for that purpose
Yes,
alone.
that's where you get your high voltage. It's a high voltage
Correct.
pump. So
Exactly.
if you only tapped that high voltage transformer one time with power, you wouldn't have jack and squat in your capacitor.
Well, you would have power for that millisecond of time.
Yeah, for a very small little fraction of a second. But if you sat there,
So if
and
you
went
were a
tap,
microorganism,
tap,
it would
tap,
last your whole
tap,
life.
tap, but you went tap, 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 and then discharge the high voltage capacitor, you're going to see a much different spark coming from that capacitor. That's what I tried to explain to people, is it's like you got to have that rapid tapping to get your high voltage built.
You're saying as Colin was using the buzz coil, or basically a
Just a high
Tesla
voltage.
coil, to create high voltage
To go from the bottle to the ground to cut the rock.
to cut the rod.
And like I said, if I could leave my bottle connected to the ground and I can put a
Did you post
switch.
that link in the
magnet
chat yet?
switch. Yeah, I put it. I thought I did. Look in the yeah, under my comment earlier
You
about.
put it in the private chat, sorry.
I put it in the
Private
StreamYard chat.
Okay,
Yeah,
so-
yeah. I couldn't put it on YouTube anyways because yeah. Uh-oh. I'm sorry for the crap video.
The audio coming?
Yeah, I hear it.
You can see the sparks on the glass bottle.
Down the plastic bucket lid down on the ground. Turn the light off, you can probably see it better here in a second. Maybe. I didn't have any editing tools, I just had my camera.
You use your phone camera?
Yeah. And when you hear the arcing changing, that's when I'm messing around with the Variac. But right now I'm just touching
Is
the
that
top
glass
of it.
again?
What?
That's a piece of glass?
I'm holding a metal rod in my hand, and there's a metal spike coming out the top of
You
my.
sent me a different video. It was a piece of glass you got. It wasn't glass.
No, there is a glass down there. Should be two glasses. There's a glass sitting inside of a glass, and they both got coils on the outside of it. And I put water between the bottom glass and the top glass.
Oh, there you go. There it is. That's the video. What's
Yeah.
on there?
So you went too high, too low.
Did you smell ozone or anything like that?
Oh yeah, you definitely smell ozone when these things are running,
I don't know why I like that smell.
right? It's such a
I used to have an ultraviolet bulb running forever in the AC closet.
right
They say it's damaging, but I don't know.
damaging to your eyes, that's for sure. There it goes.
Like,
No, I had an issue with that once.
they say
blinded
they,
almost.
they pump ozone because it and to keep people playing, you know, like they pump ozone for the AC that work, and so people can't like gives like you know like keeps you awake.
So that was a glass on top of the glass with some water, and you had
With
a coil.
Here, I'll show you. Hold on a second. Let me go find the other link. Ah,
And the arc was not going through the coil, you're saying, it was going through the glass.
it's going through the glass.
Right. And you're generating
that
flyback bolts to the coil to create high voltage induction field. And it made the glass arc instead of the spark plug. The glass became a spark plug.
So that's me playing around with the Variac, going up and down with the voltage. And if I hit just the right spot, it'd be like.
Gerald from W Light for Truth said glass has capacitance, which makes sense. Everything that's got mass probably has capacitance, even if it has no water in it.
So I was using this spark gap to ring my Tesla coil because you can't see it real well in the dark, but there was like 6 turns of like 12 gauge wire going around the Tesla coil. Secondary. It's like
6
up
turns.
above. Yeah, 6 turns is all I had. 6 turns of 12 gauge wire.
Yeah, but you already had the neon transformer pumping that.
Well, I was using the neon transformer to run the voltage through the primary coil.
Which had
And
6
what I was
turns.
doing was my secondary was producing the spark, even though it's connected to the ground. That's all it was connected to was the ground. So
Technically, the neon coil was the primary, was the secondary. And the primary. There is no
The
primary
neon
secondary.
sign transformer
Coil.
what's the driver?
There we go. Yeah, but the grid was your primary, and the neon coil was. I mean, yeah, the
The neon
Variac
sign
was
transformer
secondary.
was my voltage source, or my voltage source.
Every
And
step of the way, there's a transformer though, getting all the way to here, to the spark, which then gets transformed into the air. You know, it gets, I guess, distributed.
and how does the power get from the power company to my house? They turn the magnet wheel that makes electricity. And yes, I was afraid I was going to get nailed with 7,000 volts for some reason.